Okay, so trig, we're in 1.5. There's very little to do on the board. This is almost all calculator use lesson. So step one would be locate a calculator and turn it on. And then step two would be join me on page 16 where we can work through some problems together. Are there any of you guys that do not yet have the permission slip kind of thing done to get one of the big calculators? Need a loaner? You can't figure it out on yours. I'll lend you one for the period, and you can decide what you like better between figuring out yours versus just jumping in on ours.
I hope everybody enjoys this for the rest of all time.
Yes.
Okay, so if we're going to do number one, we may need to tweak a setting to make this work. But in theory, number one should be as simple as just punching the sign button.
What page was it? I'm sorry.
Page 16. Just hitting the sign button, 27.4, and hitting enter should be our game. And what I'm hoping the screen says to you is 0.4601, but if it does not, we just need to change the setting and it's not that big of a deal.
Is it okay if we did that for homework last night?
Yeah, I guess maybe if your answers are going to be okay.
Okay.
Yeah. So one, I got a 0.4601. If you did not get that, hit the mode button.
Do we have to clear it first?
Nope. Just hit the mode button and you'll see down the third line of choice is radian versus degree. Yours is probably darkened on the radians. So use the arrows to go over to make the degrees darker. Hit enter to make that your selection. Hit clear to get out of there. And you don't have to rekey it in, just hit enter again. It still remembers what you typed. And now it should say 0.460199 and stuff.
Yep.
Anybody not showing up a 0.4601 blah,
Can you say what to type there again?
Yeah, just type what the problem said. Having your book on page 16 will help you, but we just punched in sine 27.4. What would be the next problem that you're going to need some advice about? Which one will be a harder one? 7 is correct. Why is 7 harder than 1 through 6? Yeah, cotangent is not on your calculator. So to do cotangent of 85, what can you do with your machine?
Oh, wait, can you go? No. Wait, can you hit the second button and press tangent?
No, that's not bad, but we're going to hit tan.
Okay.
85.2. Hit enter. The screen will show you an 11-ish. Okay. Then how can we turn tan, which we have, into cotan, which we want? How can you turn tans into cotans? Flip it. So our calculator has a flip it button. If you go down under the yellow second button, there's an alpha button, there's a math button, and then there's a button that says x to the negative 1. Just hit the x to the negative 1 button. Negative powers flip thing. That's what that's for. And then hit the enter button again. And you're going to show a 0.08. That's what we're after. This should be an easy homework because all you have to do is push the right buttons in the right order, but historically it gets frustrating, especially if you don't jot down a note or two as to what buttons we just hit, because we're going to continue to do different sections, and if you trust your memory, it may just sort of blend. Okay, so I doubt if you needed a note for number 1, but you might want to write a note to yourself for number 7. We punched in tan 85.2, hit enter. We hit the flip it key, which was x to the negative 1, and we hit enter again, and that turned out our answer there. Anything 1 to 12? 1 to 12, I would title Trig. If your book's handy, feel free to write a note to yourself in the margin or something that 1 to 12 you're doing Trig. 15 to 26, we're doing a thing called inverse Trig. So if you want to make a note to yourself in the book, 15 to 26 is inverse Trig time. That might be helpful to you. Another helpful note off of this, and you could either write it in the book or write it in your own notes somewhere. Inverse trig gets you angles. What we've been doing the last 3 days is I give you an angle and you do trig. You come up with a fraction for that. What we're doing today on 15 to 26 now, the fraction has been done for you. Granted, right here it's presented to you as a decimal, but decimals are fractions. That's the same thing. So they're presenting you a decimal fraction, however you want to look at it, and they're wanting you to reverse the process back to get an angle. So here's what 15 is about. 15, you do sort of have an inverse sine button. Okay, 15, that sine negative 1 is an inverse sine. That's how it's read. Deceptively, this has nothing to do with the button we just pushed. Okay, the button we just pushed had a negative 1 on it. That has nothing to do with what we're doing right now. That negative 1 button is used anytime we're flipping. But there is an inverse sine button. Does anybody see the inverse sine button?
Okay, so do you hit second and then hit sign?
You'll hit second and then hit sine. You can see it in yellow above the sine key. So if you want to access the yellow stuff, you have to hit the yellow button first. Some of the buttons have green things on them. If you want to access the green things, you hit the green button first. That's just how those buttons are. So what we want to hit right now is second sine, 0.4791, hit enter, and I'm showing around a 28 and some change. Anybody trouble showing 28 and some change? Okay. Again, our objective was inverse trig is trying to find us blank angles. Does 28 feel like an angle-y kind of number? A 28-degree angle, does that feel like an angle? 28 degrees? Yeah. It's, between 0 and 90, like that kind of stuff. So if you want to jot a note down for 15, just in case you're going to forget something maybe later, maybe jot down some ideas like this is inverse trig. Inverse trig gets you angles. What we hit here was second, sine, and then the number, and got it. What's the next one in that group that'll be harder than that? 21 is correct, because you do not have an inverse cotan button. So what we're going to have to do for this, it's the opposite of what we did up top. Like 1 to 12 is opposite of 15 to 26, which means two things. We need to do the opposite stuff, but we also need to do it in the opposite order. So up on 1 to 12, when we had things that needed to be flipped, we flipped at the end of our process. So on 15 to 26, when we're going to need to flip, we're going to need to flip at the beginning of our process. My usual analogy each year I'll make is it's kind of like they gave you a bad present. Sometimes you get a bad birthday present or a bad Christmas present. What do you do when you get a bad Christmas or birthday present other than regift it? You have to potentially no. Well, I mean you do it first, but then you handle it behind the scenes after the guests go home. What do we do with your bad birthday and Christmas presents?
Return them?
Yeah, we return them, we exchange them. We'll show up at Target with or without a receipt and be like, do you have the price on the giant stormtrooper that we can't fit in Joseph's room? $39.99, we'll take it. What do you want to get, son? Baseball cards. Okay, here we go. We'd like to exchange our giant stormtrooper for some baseball cards. So 21, they've offered you a present you don't want. On 15, we were in good shape. They gave you the sign, and they wanted you to go to work with it, and you were happy because you had a button that did that real nice. Okay, on 21, they're saying to you, here's a cotan fraction, and you're thinking, well, that doesn't help me, but it can help you if you exchange it. Okay, so on 21, our first move is going to be 0.5234, hit the flip it button. Hit enter, and it shows you 1.91. When you flipped it, you no longer have useless cotan, you have useful 10. 10 is your friend. So we no longer have a cotan problem that's impossible. By making that exchange, we now have a tan problem that's entirely possible. So now we're going to go second tan. And instead of re-punching in 1.91058, instead of punching that whole thing in, if you look on the bottom row of your calculator in yellow, next to the decimal on the negative key, in yellow it says answer. We're going to go yellow button, answer button, and that will bring that answer back to you instead of you having to punch in that whole answer. You don't want to punch in 1.91. That just brought it all back to you. Hit enter, and I'm seeing 62. Anybody not seeing 62? And again, think back to the moral of the story. This type of section is called what kind of trig? Inverse trig. Inverse trig is trying to find you angles. 62-degree angle, does that feel like an angle-y kind of number? Yeah, we're looking to get stuff between 0 and 90. So to recap what you did on 21, they gave us a bad answer, so we're going to exchange it. 0.5234, we hit the flip it key, and we showed up 1.91. Then we're ready to do our inverse trig. Inverse trig will always hit the second button. So second, tan in this case, bring that old answer back and hit it. Something about that. Then we'll cut down to 27. 27 is going to involve a three-step plan. A little bit of my board use or your page use, as the case may be, and then a little bit of calculator use, and we're just making sure that the old things we've been doing agree with our calculator usage. So for 27A, it says sketch the angle in quadrant 1, mark stuff that I'm going to mark in a different way than they say. I'll stand up for this. So they say for 27, cosine is 3/5. So quadrant 1 is headed right 3. Well, maybe just to diagonally where? Up, left, up, right, down, left, down, right.
What? Wait, what?
Quadrant 1? If I'm going to make it
Right.
up and right. So I'm going to go diagonal that way. We always try to draw a triangle by headed to the x-axis. The reference angle is the one that touches the x-axis, making this be
Opposite.
O, H, adjacent. And then if we go to fill in the 3 and the 5, we need to think about Oscar and his friends. So 3, 5 are unknown. Unknown for now. 3, 5, triplet friend. That is indeed a 4. Okay, so we just accomplished A. We drew the angle in quadrant 1. We marked down what everything is. Our book doesn't use O's, A's, and H's. They use other letters for some reason, and I don't acknowledge that. B, anytime in this book that they use the word exact, exact is their secret code that means we're not using the calculator for this. We're looking at a board, we're using our mind, we're using a chart, we're doing something that we've done to this point of the year. So they say find the exact value of sine. So looking at this picture, what is the value of sine?
Or 5.
4/5 is correct. So that was A is picture, B is coming up with 4/5. C is, sit back down for me and go to my calculator. Whenever they use the word approximate in any of the directions, approximate means it's calculator time. We don't need to draw stuff, we just need to use our machinery. So for C, they say find the approximate value, use your calculator, by using the inverse buttons. Again, inverses get you, inverses will find angles. So we're going to find an angle with an inverse button. Then, without clearing the calculator, we're going to find what they wanted. So for 27, we're going to go and do the inverse cosine of 3/5. So how am I going to do the inverse cosine of 3/5? Second.
Sine.
Yeah.
Uh,
Second.
Cosine.
Cosine.
oh, okay.
3/5, you can punch in, I think we might need to close the parentheses on this because we made a fraction, so to keep the 3/5 as a group, we might need to close the parentheses off. I'm going to do that just to be safe. I'm going to hit enter, and at that point I show up at 53, which doesn't surprise me totally because I just did an inverse, so I'm expecting an angle. 53 feels like an angle to me. So we're halfway through the directions. They said do the inverse function, which we did. Now they want us to find what they asked for, which is they want us to do sine of that 53. So I'm going to push sine. And then am I going to repunch in the 53? No. How am I going to access that?
Second answer.
Second answer. And it shows me up a 0.8. Do you know offhand if 4/5 is the same as 0.8? Yes. If you didn't know offhand that 4/5 was the same as 0.8, I would ask you to punch in 4 divided by 5 and see that it's 0.8. Since these two answers are in agreement with each other, we have high confidence that everything is correct. Yes.
Did you punch in 3/5? Because 3/5 gets you 53, but it's 4/5.
Cosine was 3/5. I did punch in 3/5. I'm keying in on the book at 27, how it says cosine is 3/5. That's what I'm punching. Second cosine 3/5. Sine ends up being 4/5. That's in agreement with the 0.8 that we ended up with at the final answer. You follow? We're starting with the foundation of what they wrote us in the book. The cosine of 3/5, I did second cosine to lead me to a 53. On the picture, you don't have to mark it on the picture, but 53 lives there. Then if we do sine of 53, the 4/5 shows up on the calculator just like the 4/5 showed up on the board.
I did not get 4/5.
0.8.
I didn't get that. It just says error.
Okay, so let's go. Did you have second cosine to get you to the 53 ever?
Yeah.
Okay, then once, repunch that, or just use the second entry thing to bring that calculation back to the present moment. Okay, so it's showing you a 53 now?
Yeah.
Then just go sine, and then the answer button is yellow and then bottom row. 0.8. Just, let me see. Something weird happened there. Let's go. So we'll go back to that, and then we're just going to go sine, yellow, that. Follow?
Yeah.
Sum of 27 to 32 involves flipping, and so I'm going to leave that to you, and this is where you may get a little flustered when you're doing this on your own, but we'll see how it goes. Keep in mind, the way I would imagine this group, 27 to 32, it's kind of like the offspring of the other two groups. Okay, 1 to 12, we had a process. 15 to 26, we had a process. You're going to have to do both processes. Okay, you're first going to do a problem like 15 to 26, which if you had to flip, when were you going to flip 15 to 26? First or last? First. Then you're going to do the process like 1 to 12. And on 1 to 12, you were going to flip last, second, however you want to say it. So if they want to go nutty on 27 to 32, it's possible you might flip first and last. And sometimes I jokingly refer to that as a flipping sandwich, because you're going to flip, do some math, flip again later. But 27 to 32, you're going to do the inverse part of it first, which might or might not involve a flip, but definitely involves a second key, like 15 to 26 did. Then once the answer shows and you have your angle, then you're going to do a problem more like 1 to 12, which might involve a flip also, but if it does, you'll flip at the end.
Okay, I'm confused on why you did the second cosine key.
Because 27, they gave you cosine, so what you can do is inverse cosine to undo that and show up an angle for you.
Oh, okay.
Does that make sense? Because if you punch in, like, if you punched in cosine of 53, it would show you up to 3/5
Okay.
as a 0.6. But
Yeah.
something there. 33 to 38, they're asking you to find theta. That's our Greek letter friend. Anytime you see theta, that's referring to an angle. If we're trying to get an angle, we're having to do an inverse, which means on the calculator we're hitting the yellow button first. And if a flip appears when we're doing inverses, flipping would happen first or last? First. So 33 to 38, if a flip presents itself, the first thing you're going to do is flip. Helpful hint that some years I've forgotten to give on this day, on the ones with negatives, just don't worry about the negatives. Just punch in the problems without the negatives. The negatives are not necessary. We don't need them, and I think they actually jam things up a little bit. So 33, we're on a goal of finding an angle. So in this one, do we need to flip? No, because sine is fine. What would be one where you'd have to flip because it's not as fine?
36.
36 would be one we'd have to flip. And again, if we were flipping, we'd have to flip first. But 33, we're ready to get the angle. So we're gonna go, how are we gonna get the angle?
Sine.
Not quite. Second sine. Punch the number. Mine shows about a 40. Your calculator will only ever give you reference angles. By reference angles, I mean things between 0 and 90 that essentially belong in quadrant 1. 33, you notice there's a little bit extra at the end of the problem, which didn't matter till right at this moment. What they're asking us to do now is figure out where in the larger world this 40 is supposed to fit in. Where was 0 degrees historically? On the right. Where's 90? Up. 180, 270, 360. So on 33, when they want us to be more than 90, less than 180 is what the end of that line means. The last stuff there they typed is telling you get in between 90 and 180. We'd be somewhere like this. The 40 is the reference angle. Where do reference angles always live? By the x-axis. So here lives a 40. How could you use basic math to figure out what best number that is somewhere between 90 and 180? 180 minus 40. If you do 180 minus 40, this is going to be 139 and some change. We could just go 180 minus and then use that answer recall button 139 point, they say 2 decimal places, so I'll round that off to be a 70 because a bunch of 9s are on my screen. They also say to do something about minutes. I don't care about the minutes. You don't have to do anything about the B's for the minutes. Just skip that. At its face, it should be a relatively easy homework because you're just pushing buttons most of the time, but sometimes the order of the buttons matters and it gets kind of frustrating if you can't get it to agree, and then we'll troubleshoot things tomorrow. The only writing you're going to need to do other than writing down your answers, 27 to 32, you're going to need some pictures of Oscar and his heap of apples. 33 to 38, you may or may not even need the sketch. You might be able to just imagine where it is and do the math. If the sketch helps you, make a sketch, but it's not mandatory to do a sketch 33 to 38. Mandatory 27 to 32 to draw a picture. Question about 16-y kind of stuff.
What was the order for ones like 21 where it's
We would
protein
go
and flips?
point 5234 flip first and hit enter.
Okay.
And that would show you another random decimal number that has no meaning.
Okay.
Then you'd go second 10 in this case of that answer recall yellow thing and hit enter again a second time, and that should show you something that's feeling like an angle. Peyton, you'll need a calculator from this to do this lesson. So, like this.
Does he have the form? 'Cause
seems
I
like
can
a
always
sun-
get it to him.
Seems like a Sunday job. He should have gotten the form. He was here the first day.
Okay.
So it's just a matter of getting him the actual machine.
Can you explain how to get to the point 8 again?
Okay, so we would go on 27, second cosine, 3/5, hit enter. And that should show you a 53-degree angle. Then sine of that answer using that yellow button. Coordinate. Is that okay?
Thank you.
You're welcome. Anything else, page 16?
So wait, I'm sorry. For the 27 and 32 group, do we always hit the second and then whatever, like, it's cosine, tangent, or whatever? Okay.
Yeah, you're going to start off, when it's possible your very, very, very beginning start might be a flip. If they
Okay.
give you a weird one, like on 29, they give you a weird one instead of a nice one,
Mhm.
secants mean, that one you'd have to start by flipping.
Okay.
But on all the rest of them, you start with second, whatever trig word it is.
Okay.
Anything else, 16? Call that quits for that.